Welcome, my dear students in Prep 3. Today we will start the first lesson in algebra in the second term. In this lesson, we will learn how to solve two equations of the first degree in two variables. Okay, we can solve it graphically or algebraically. In this session, we will know how to solve it graphically. In this case, we will draw the function of the two equations. So we will get two straight lines. As we studied before in the first term, if the two straight lines intersect in one point, in this case, it means we have only one solution. This solution will be the coordinates, the x and y coordinates of the point of intersection. So here we have a unique solution, which is x1, y1. If L1 and L2 are constant, the same line, in this case we have infinite number of solutions. If L1 and L2 are parallel, there is no intersection point, so we don't have any solution. So the set of solution is phi and the number of solution is 0. Let's take this exercise. Find the solution set of each of the following graphically. As we studied in the first term, the first step, I'll put y alone in the left hand side. Then I'll assume values for x and get the value of y. Then we will draw. The first equation, 2x minus y equals 5, it means y equals 2x minus 5. I'll prepare the table. If x equals 1, I'll substitute in the equation. So 2 multiply 1 equals 2 minus 5 equals negative 3. So here we have the first point 1 and negative 3. By the same way, I'll get another 2 points. The 2 points here is 2 and negative 1, 3 and 1. So we have 3 points. We can draw this straight line. Actually, we can draw the straight line using 2 points. But to be sure, we will make one addition point to be sure for check, okay? The second equation, x plus 3y plus 1 equals 0. It means y equals negative 1 minus x all power s or divided by 3. Negative 1 minus x or divided by 3. I'll assume x and substitute in the equation to get y. Now I have 3 points, negative 1 with 0, negative 4 with 1, and 5 with negative 2. Now I can draw the two straight lines in the same graph. I'll draw the two straight lines. In this case, the two straight lines intersect in one point. So this is the solution. This point is 2 and negative 1. So x is 2 and y is negative 1. So the set of solution is the ordered pair 2 and negative 1. Another exercise. Find the solution set of each of the following graphically. The first one, y equals 2x minus 4. The second one, 4x equals 2y plus 8. By the same way, choose values of x, substitute in the equation and get the values of y. We have 3 points and belongs to the first straight line, 0 and negative 4, 1 and negative 2 and negative 1, negative 6. The second straight line, y equals 4x minus 8 over 2. By the same way, we get 3 points. Then we will draw the two straight lines. In this case, the two straight lines are constant. So we have infinite number of solutions. How can we write the solution set? Of course, in this case, we can't use the listing method to write the solution set because we have infinite number of solutions. So we will use the description method. Okay, so the set of solution is the set of ordered pairs x and y such that y equals 2x minus 4. This equation, y equals 2x minus 4. You can write this or this equation. Okay, one of them. And x and y belongs to R2. R2 is the plan. R by R plan. Okay, so the set of solution in R2 is x and y, the set of ordered pairs x and y, such that y equals to x minus 4 and x and y belongs to R2. Here we have another exercise. Find the solution set of each of the following graphically. Y equals to x minus 2 and 2y minus 4x minus 2 equals 0. I put y on the left hand side. So here y equals 4x plus 2 all divided by 2. Choose values of x, for example here 2, 1 and 0, and substitute in the first equation to get y. Now we have 3 points, 2 and 2, 1 and 0, 0 and negative 2. By the same way, in the second straight line, negative 1, 0 and 1, and substitute in the equation to get y. So we have another 3 points. When we draw the two straight lines, in this case the two straight lines are parallel, so there is no intersection point between them. And as we said before, there is no solution set. So here the number of solutions 0 and the solution set is 5. Okay, so if you want to solve two equations in two variables first degree, we will graphically we will draw two straight lines, each one represent one of the two equations. Then if the two straight lines intersect in one point, this point is the solution set. Then we have one solution. If the two straight lines are constant, in this case we have infinite number of solutions. We write the solution set using description method. If the two straight lines are parallel, so in this case we don't have solution set. The number of solutions is 0 and the solution set equals 5. So we can decide if the two equations have one solution or infinite number of solutions, or they doesn't have, or they don't have solutions, by calculating the slope. We have two straight lines. We can calculate the slope of each straight line. If m1 doesn't equal m2, we have different straight lines. So in this case, the two straight lines will intersect in one point. Okay, so we have only one solution. If we calculate the slope of the two straight line and m1 equals m2, in this case we have two options. Okay, the two straight lines can be parallel or coincident because they have the same slope. How can we know if the two straight lines are parallel or coincident? I'll find the point of intersection of the two straight lines with y-axis. I'll put x equals 0. Okay, I'll put x equals 0 and calculate y. If the 2 points are equal, the two intersection points are equal, it means that we have two straight lines which are consonant. Then we have infinite number of solutions. If the 2 points are different, in this case the two straight lines are parallel, so we don't have, okay, so we don't have any solution. The number of solutions equals 0. Okay, so if you want to decide the number of solutions of the 2 points, or to determine the number of solutions without a graphing, in this case you will calculate the slope. We studied before in the first term how to calculate the slope. If m1 doesn't equal m2, in this case the two straight lines are intersecting in one point, so we have only one solution. If m1 equals m2, in this case you should determine if the two straight lines are parallel or coincident. They can be parallel or coincident. The simplest way to know if the two straight lines are parallel or coincident, we will calculate or determine the point of intersection with y-axis. It means x equals 0. So I'll put x equals 0 in the first equation and get y. I'll put x equals 0 in the second equation and get y. If they are the same, it means that the two straight lines are consonant. If they are different, it means the two straight lines are parallel. If the two straight lines are consonant, it means that we have infinite number of solutions. If the two straight lines are parallel, it means we don't have any solution. Okay, so the solution set here is 5. Here we have, for example, in each of the following, determine the number of solutions of the equation. The first one, we have y equals x plus 2. And here we have y plus 2x equals 8. We can calculate, as we said before, I'll calculate the slope of the first one. The slope is the coefficient of x because y is alone in the left hand side. So the first m1 equals 1. So here m1 equals 1. m2 equals negative 2. Here the slope, as we studied in the first term, equals negative coefficient of x over coefficient of y, or if they are in the same side. Okay, so negative 2 over 1 equals negative 2. So we have different slopes. The two slopes are different. m1 doesn't equal m2, so we have one intersection point. It means that we have only one solution. Okay, the second one, 3x plus y equals 7 and 6x plus 2y equals 14. Let's calculate the slope. Negative coefficient of x over coefficient of y, because x and y are in the same side. It means negative 3, the first one, and the second one will be negative 6 over 2. It means also negative 3. So now we have the same slope. Okay, so I'll calculate the point of intersection with y. I'll put x equals 0, so in the first straight line, so y equals 7. So this is 0.1, 0, and 7. I'll put x equals 0 in the second one, so 2y equals 14. It means also y equals 7. So we have the same point. So the two straight lines are consonant. In this case, we have infinite number of solutions. Okay, we have infinite number of solutions. That's all about our session today. The next session, we will know how to solve two first degree equations in two variables algebraically. Okay, thank you very much for watching. I hope you have understand our session today. See you next session. Goodbye.